Hello, and welcome to today's special webinar event, Top 10 Considerations When Choosing a Zero Trust Network Access Solution. Webinar is sponsored by Zentry Security and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, there are a few things you should know about this webinar. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to the questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. We have links to get started with Zentry Security and to a Zentry case study. We also have PDFs from Zentry for a data sheet and a solution brief. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky attendee on the live event. Of course, you must be in attendance during the event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. And finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic content. So it's my pleasure to introduce our presenters today. We have Brian Embry, who's Director of Product Marketing, and Asher Kanoon, who's Vice President of Product for Zentry Security. Brian and Asher, welcome to the webinar.
Thank you very much, Scott.
Yeah, Brian, take it away.
Okay, thank you. And moving right along. Good morning, good afternoon, good evening, everybody. Thank you for joining Asher and I. We hope this is a very educational webinar on ZTNA, Zero Trust Network Access. He and I have been in this field for a few years, and I'm also looking forward to Asher's demo toward the end of the slide deck. But let's get going real quick. I thought it would be good for us to kind of get into a definition, I guess, if you're not familiar with ZTNA. Gartner has a pretty good definition. And, you know, as you're probably all too familiar with, today's networks weren't really designed with security top of mind. In the old days, users were trusted employees, and they really only needed a password to get access to applications. And those applications were deployed on premises in a corporate data center. And that whole idea seems kind of quaint now, given that there's lots and lots of cloud migration and the number of breaches and attacks and the number of threats that everybody faces pretty much daily. ZTNA sort of turns that idea on its head. Basically, no one is trusted at any time, and they must verify who they are to get access to the resources they need. ZTNA does that by creating a logical barrier around applications, essentially based on a default deny posture. Applications are hidden from unauthorized users, and they're removed from public visibility. That is often called the dark cloud support. But it also makes east-west traversal really difficult. Access is globally enforced based on each user's trust level, and policies restrict access and follow users regardless of their location. That all combined significantly reduces the attack surface. Unauthorized users have much higher difficulty getting in, and if they do get in, they can't move around as easily as they sort of used to. So what does the typical ZTNA architecture look like? Here's a diagram that shows users on the left accessing applications in the cloud and data center on the right. In between is the cloud-based ZTNA service. It brokers connections between users and applications. Those connections are encrypted with TLS by default, and the connections are initiated inbound by the service from the application. So that keeps applications hidden from unauthorized users, and that reduces the attack surface. Policies that I mentioned, they're applied by the service, and they govern which applications users can access, and those policies follow users regardless of their location. And that's the identity and context-aware access. Those policies can be applied to groups as well, so that, say, sales teams, they all have access to specific applications, and while marketing groups have access to others. Asher, any color commentary there? Did I miss anything?
Just to highlight, this is cloud native, as Brian mentioned. The ZTNA service is a um, multi microservice deployment that's globally available. On the left side, the browser is all that's needed. On the right side are resources behind a resource connector. These resource connectors are hardened devices with only outbound connections, so there's no way that uh, someone other than the service is getting in.
Cool, thank you. So how did we sort of get here? The architecture itself has been around for about 15 years, but really only has seen sort of recent rapid growth. Gartner is predicting that because ZTNA lends itself to some significant use cases, that we'll be seeing broader adoption. Like 80% of new digital business for partners will be leveraging ZTNA this year, and that 60% of organizations, they'll begin phasing out legacy VPNs in favor of ZTNA next year, and that 40% of enterprises will be adopting ZTNA for other use cases next year as well. And we'll talk about some of those use cases in the next several slides. But really, ZTNA lends itself readily to enabling secure remote access to dispersed, distributed workforces comprised of employees, contractors, third parties, and in organizations of pretty much all sizes. So what are some of the top 10 selection criteria for ZTNA? We put together a list of sort of key features and functionality that really must be there for rapid deployment, quick adoption by all users, both technical and not so technical. And most importantly, really increase productivity, collaboration, and security. And those are the key factors for pretty much any business. So we're going to go through kind of this list and talk about each one and why it's important for a ZTNA experience. So top of mind clearly is a simple user experience. No solution is really going to make users happy and collaborative and productive if it's a pain to use. Lots of VPNs were like this in the old days, with sort of complex clients that users had to manage and troubleshoot or even call IT for support. And some ZTNA solutions offer clientless modes where all users need is an HTML5 browser. So really, times have changed. VPNs were also really designed back in the days when trusted employees and only a few trusted employees needed to get access to applications and resources that were located on premises in a data center. But as the pandemic has showed, but even before the pandemic, workforces are really more distributed, remote, and sort of matrixed today. You've got employees, third parties, partners, etc. They're all accessing applications in the cloud, and they want to access those applications from the device of choice pretty much at any time. And that's helping to sort of cast a light on aging VPN systems. Users really are getting accustomed to rapid access to the things they need to do their jobs, and really ZTNA makes that possible. Clientless modes, where all users really need is a browser to get access, really go a long way to making that whole process easier, both for them and for IT. So unlike traditional VPNs, ZTNA solutions don't offer network level access either. Access is restricted to a specific set of applications, and those applications and that set of applications are specified by IT using policies. ZTNA must still support access to a wide variety of applications and resources, because users don't just access one or two applications in the cloud. They're accessing remote desktops, published apps, custom web applications, or even legacy apps that have had a sort of a front end added. And then there are all the interfaces on top of things like switches, routers, and firewalls that IT needs access to keep them up to date and keep the business running. And so the ZTNA solution really has to support a wide range of protocols to do all of this. Things like RDP, VNC, all that kind of stuff, to make sure that all users can access all of the applications and resources they need to get their jobs done. At the same time, really, it's all about the data. Businesses rely on it. It's effectively the lifeblood, really, of any business. Threat actors really much are really using data and more effective and more sophisticated methods of trying to get at that data. All the hype surrounding things like DevOps, containers, orchestration, machine learning, AI, all of that for regular business is also being employed by threat actors to try to attack corporate data. So securing that data, which is no surprise really, is critical. ZTNA solutions are architected with security up front rather than like older systems where security is sort of tacked on because trust was assumed. ZTNA solutions leverage TLS, the successor to SSL, and TLS uses complex hashing algorithms on both ends and really sophisticated encryption to keep data secure as it traverses networks. And this is always enforced. It's not possible for a user to turn off encryption or use some sort of shadow IT to get at applications and data really without it. The whole architecture enforces encryption end to end to keep data safe throughout the transaction. And as I've mentioned, users are limited to accessing specific applications to do their jobs. They can't traverse the network and find applications that they're not supposed to access. ZTNA prevents that sort of thing. One of the terms you'll run across when reading about ZTNA is the principle of least privilege. That's effectively meaning that administrators can restrict users to just the applications they need to do their jobs. For example, if like a vice president needs access to a wide variety of applications, that's fine. IT can set policies to do so. But on the other hand, if a lowly marketing type like me just needs access to one or two, that can be set as well. You don't need to enable wider access to any user and then trust that they won't go sort of traipsing off around the network just to see what's kind of going on. So enforcing policies and access means that you can get very granular about who accesses what. And you can sometimes even enforce that access based on time of day or location. And so then in the unlikely event of lost or stolen credentials and someone gets in, that so-called blast radius is limited as well. Unauthorized users can't find other applications on the network to do further damage if they get in. One of the critical factors is multi-factor authentication, or MFA. It's really crucial to enforcing identity-based context and limiting trust to only users that should be accessing resources. Threat actors focus a lot of effort on stealing credentials, especially as the pandemic shifted workers remotely a couple of years ago. It's sort of the old way of allowing users on the network with just a username and password is really no longer sufficient. And then we have applications sort of coded with front ends that require complex passwords that include punctuation and numbers and stuff like that, which affect the effect of that is that it makes passwords complex and actually quite difficult to remember sometimes. And a better way is using MFA with things like RSA, Google, or Okta, and that uses mobile phones and text messages and codes and things that actually make it virtually impossible for someone to steal credentials and then get into a network because they don't have those secondary codes or the phone itself. Really, MFA makes it a lot more difficult for an unauthorized user to get into a network. Asher, anything to add there on MFA?
Yeah, so one of the use cases we're seeing a lot is adding MFA to backend resource of the applications that don't have it already. So when ZTNA or Zentry Trusted Access, when that sits in front of a legacy application or something like an old terminal emulator for like a a older system that's been around for 20 plus years. One of the nice things about uh, a ZTA solution is that you can actually add MFA without actually uh, changing legacy applications. And this is just at the access layer. You can add it, and then they can single sign on using a different method to the backend application. So it's adding similar authentication methods across all of your services, even if the service itself doesn't support it.
Thanks. That's also good to know. And in combination with MFA is single sign-on. This is often mistaken for making it actually easier to get into the network. But instead, it's a process that allows users to securely access multiple related applications with a single set of credentials. So employees, customers, partners, etc., can sign in once to access their authorized apps, and that streamlines the whole process. It works through a relationship between something called the identity provider, IDP, which passes an assertion using typically SAML to a service provider, also called an SP, that goes through the authentication process. The thing is that there's a misconception that SSO makes it easier for someone to get into the network, that maybe should a master password be stolen, all accounts could be exposed. But in the case of ZTNA, SSO is integrated into the architecture, and that really means that users only need to create one solid, hard to guess password, and they don't need to write it down. So there's no need for the password resets and calling IT and all that kind of non-productive work. Workforces can collaborate better because they're really not burdened with multiple passwords, and they can quickly and easily get access to their applications. And when it's combined with MFA, it really does increase security and improve compliance with things like PCI DSS and HIPAA and other mandates. Anything to add there, Asher? I know you are a SAML expert.
Yeah, so just to add, on the SSO side, there's multiple methods. So you mentioned SAML. SAML is great for applications, web applications that actually support SAML. But there's also other methods like form fills and other ways to pass credentials to like a telnet session, an SSH session, or RDP. And you want to find a solution that kind of covers all that stuff. And we do. So we also allow for things like OIDC or OAuth, which is used more on the consumer side. But we've seen more and more organizations and SaaS applications giving the ability to sign in using your Facebook credentials or Google.
Yeah, and in fact, we're seeing once in a while we see things like using there's even facial recognition and things like that for MFA and SSO from time to time. Anyway, on reporting and analytics, that's sort of key to making ZTNA valuable to IT, and that's determining who's using the network and who's accessing applications and when they're doing it. It's crucial to providing insights into behavior. IT can even find insights into sort of spurious behavior that may indicate an unauthorized user. We had a customer one time who was using reporting to find a user that was accessing applications at a time of day that was kind of strange. Sometimes you can even use location information and find out if a user is accessing an application from some odd location like Fiji, which would indicate most of the time that that's a stolen device. But or maybe there's an unlikely mix of usage, maybe among 2 or 3 users. That might indicate that the network is under surveillance by possible threat actors. So really, IT wants to know this information so that they can plan accordingly, ideally for happy things like business expansion or additional licensing, rather than looking at possible threats that are being leveraged against your network. One other thing is that a true ZTNA solution really should offer a way for IT to quickly, securely, and remotely administer heterogeneous IT infrastructure, switches, routers, firewalls, etc. Those systems are critical to keeping the business up and running, and that collaboration flowing smoothly among people who are accessing applications. So doing things like updating ACLs and firewall rules and things like that. At Zentry, we offer something called transient authentication. This is effectively a passwordless single sign-on that generates specific privileged credentials. Administrators can get access to these systems for a needed update or a rule change, as I mentioned, or something like that, or potentially even troubleshooting. And it lets them do that remotely. So at the top of the hour, I mentioned sort of what are the key use cases driving ZTNA. The three primary ones are third-party remote access. Workforces are more matrixed than ever, and those partners, consultants, all need access to applications, and you want to make it easier to access those applications. You typically don't want to deploy a VPN client to a system that's either unmanaged or somebody's home device. You want to make sure that employees have access remotely and that they can access the resources that they need to do their jobs. And you also want to enable zero trust remote access. You want to make sure that users are identified upfront and that trust is established before they can access those applications. And that's different from sort of the old days when networks had a connect first, authenticate second model, and trust was assumed. We really want to flip that on its edge because that significantly reduces the attack surface. So comparing these to sort of VPNs in the past, the sort of the old way of doing things, VPNs really enable broader network level access that allows possible sort of east-west traversal, and they may require complex clients that I mentioned earlier. You don't really want to install those complex clients on unmanaged devices and go through that process of having to install, maintain, and troubleshoot and support those kinds of devices. ZTNA really, on the other hand, limits access to specific applications and instead really just webifies that access. Simple URLs are issued and users point their browsers and off they go. Asher will show that here shortly. There aren't clients to deal with or configure, and it's really only the IT administrator is only really involved when looking at sort of the back end, looking at defining policies and things like that. ZTNA really streamlines the whole process and makes it easier for workforces to get their jobs done. In the case of employees working from home, accessing things remotely, VPNs kind of make it frustrating for everyone in a sort of work from home situation. IT often has to punch holes in firewalls, maintain all those rules and all the logic behind them. If you make a mistake, it can be difficult at best to diagnose them depending on sort of how old and how, in many cases, sort of overwhelmed your firewall or possible switch is. Sometimes if you misdiagnose that, you can create a large hole there that has to be fixed and filled. So at the same time, you've got to troubleshoot, configure a VPN client on the end device. And again, that device may or may not be managed or owned by the corporation. So then possibly you would have to get a device loaned out to the user. And you don't necessarily want to train users on that client. You don't want to support them. We've run into a number of customers who have very non-technical users who are often sort of confused by VPN clients and just really want to get their jobs done. ZTNA enables that kind of thing with a very streamlined, simplistic workflow. ZTNA doesn't offer those layer 3 connections to the networks. They're presented instead with a list of applications in the browser that they have access to and that are governed by policies that are set by administrators. and then they're required to authenticate themselves regularly. Learning that process is a lot quicker than having to figure out which VPN I need to use for which application that I'm accessing. The ZTNA workflow is a lot more intuitive, and you'll see that yourselves in a second. So looking at this from a zero trust perspective, VPNs use that traditional castle and moat approach, where the crown jewels are protected by sort of a series of shells, where trust is provided to on-premises users simply because they're on premises. This model effectively means that everything is pretty much static and relatively unchanging, and you are providing a level of implicit trust to those users, and sort of the result is that VPNs are needed for every network and must be administered and managed accordingly. ZTNA, on the other hand, creates logical boundaries around those applications. It restricts access only to users who are authorized, and it limits visibility from those who don't. That's, again, that so-called dark cloud support that helps reduce the attack surface. At the same time, because ZTNA is cloud-based service, automatic updates by vendors means that there's less to administer and manage from an IT perspective. It's really a simple matter to connect Zentry to any data center or cloud. Deployment is pretty quick and doesn't require a huge effort by the IT team to get up and running. So at this time, I'd like to turn it over to Asher to do a quick demo looking at both the user and administrator perspectives, and then we'll do a quick wrap up and get to the Q&A. And so over to you, Asher.
All right, thank you, Brian. So I will share my screen. Hopefully you guys can see it. So first we're going to look at the end user experience, and then we'll look at the administrative experience. So here is the end user portal. This is kind of the default. There's ways to kind of fully customize it with logos, colors, instructions, if any. So there's a few things you can do to customize this. I will be showing dual factor authentication. So in this case, my first authentication is AD. And then the second factor is a integration with Duo. In this case, I'm going to use the push. So my phone is asking me to approve. So give me 1 second. Okay, so I have approved it on my phone, and then now I'm in. So when we look at the administrative console, you'll see that there are dozens, maybe 100 or so resources, but I only have access to 3. And the reason for that is we have policies in place that are giving me some access based on a group. And then we have policy in place based on user and also based on the device I'm coming in from. There are certain applications that may not work from a browser, or you don't want to make them available through, let's say, a desktop. You only want them to be available on small devices, or let's say iPads. Specifically, you can go ahead and create policies for that, and we'll take a look. So in this case, I have an RDP connection. I also have an RDP application, and then I have a link to an internal application. So I'm going to go ahead and click on the RDP connection. It'll open up in a new browser, and it'll sign me in. As you can see, I'm signed into a Windows desktop, and it happened really quick. This is an HTML5 broker, which translates other protocols like RDP and allows us to get in quickly. There's some things we can do, like we can enable audio, remote audio. We can do local printing, file shares, copy paste, things like that. So I was able to get into my application or my RDP really quick. There's nothing to install. There's no clients. It's running native HTML5. The second link here is it's an internal site. It's an intranet. This also signs me in, and if you notice, it's still going through the array.zentry.ai. So Zentry AI is the system. The array.zentry.ai is a tenant that's specific to me, and then the intranet is my internal application. So it lets me in. It's going over our system. You can't directly access this link if there isn't a session, an authenticated authorized session. So we are putting layers in between your backend resources. None of this stuff is public. The only way you can access it is going through the system using a gateway. This last one is an RDS deployment. This is an application running on a backend system. Again, it signs me in, but it's only giving me access to the other a single application. In this case, it's a browser. It's an application running on a browser, but we have the ability to just give you access to a single application. So some of the benefits of this is there's nothing for the end user to install. There's no VPN client. These resources can live in multiple sites. These sites can be on-prem. You could have 2 or 3 different data centers. It could be in the cloud, but they'll all be presented to the end user in one place. And then you can host applications, thick applications that are specific to certain users on a remote system, and they can only be accessed there. And what the combination of not having an agent or client to deploy and having a system that's kind of static, that is being run by IT, what this does is this minimizes or reduces the number of calls that IT gets. IT doesn't have to deal with BYOD systems that it's not familiar with, and it can deploy systems that they're very familiar with, that have the latest patches, they have the latest antivirus, and they're doing like a hard drive encryption and things like that. So it's a way to reduce the calls by having a system that's easily accessible but also managed. Okay, so this is a quick look at the end user portal. Now we're going to look at the administrative side. So the administrative side, every organization logs into my.zentry.ai. This is a multi-tenant platform for configuration. And when they first log in, they're presented with the dashboard. Dashboard gives you some useful information about who's logged in, what browsers they're coming from, what resources they're accessing. But we also can see a few things. So there's the ability to enable anomaly detection. So the anomalies we're looking at that are configured on this system are kind of business hours, time of day type of anomalies, and location anomalies. And these location anomalies are, user A logs in from one state or one country, and then a few minutes later they log in from somewhere else. So we know it's not possible to move from state to state so quick. So this we flag as an anomaly. And there's a few things we can do in terms of anomalies. We can just detect them and just continue, or we can present some responses such as adaptive authentication. So if most users after their first login only use single-factor auth, once an anomaly is detected, multi-factor authentication is presented, so that even if a credential is stolen, we'll fall back to something like a time-based token and so on. So this is just some of the information that can be found on the dashboard. So how do we set something up? So in this demo, I have a single site, but there's also multi-site, multi-region support. So a site is, think of this as where do the resources live? In this case, we have a resource connector that's running on ESXi. It's in our lab. Once we deploy the resource connector, we also spin up a VPC, a virtual private cloud. And that virtual private cloud is all of these single tenant components that we need to run to make sure that there are things like data sovereignty. Everything is for one specific customer. There's no data leakage and so on. So once we spin up a site, then we can go and configure the rest of this. So we have authentication, different authentication methods, and the authentication methods we support are Active Directory and LDAP, Radius, and Radius is often used for all multi-factor authentication vendors. In this case, we have Duo running. There's also SAML. Right now, we don't do SAML IDP. We rely on external SAML IDPs. These can be like an Okta or a One Login, and then also OIDC. Again, this could be something like a AWS Cognito or Google OAuth. Really, this OIDC, it's often used with like consumer-based applications, but between the four of these authentications, we pretty much can support any outside vendor. And we also support local auth, and this is often used for like a fallback or for testing, where you can create local users and local groups. There's also the ability to configure SSO. This is single sign-on to backend resources. Once an authentication server is configured, then we will go and configure resources. Here we have a bunch of resources. And one thing to mention is if you look at resource names, resource types, and resource tags, this gives us the ability to actually filter here. So if I go and I put RDP, you can see it goes and filters out based on the type. If I put in Ash, it looks up Azure. So we can filter resources on the end user portal side by using any of these fields that are known for the resources. And resources can be an SSH connection back to a device, Telnet, RDP, and VNC, and then also web resources. And web resources can be direct bookmarks. Let's say your customers use like Salesforce, you can give them a web link to Salesforce. And with Salesforce, you can also do something like a source IP type of limitation so that only specific connections are allowed. Or these can be web resources that are internal. Like I showed the example of the intranet, which was an internal application running on a server that we're hosting in our data center. And within some of these, like RDP, you can go and you can enable things like remote applications. So you can allow for just a single application, not the entire desktop. And then there are other things we can do here. There's ways for, specific user authentication, or you can have some generic authentication. Oftentimes, the generic authentication is used with things like networking devices. If someone's bringing up a brand new network device and they haven't configured something like radius authentication, they might choose to put in a generic auth at first. Okay, once we define our resources, then we go and we create policies. In this case, we have a single policy, but there's a couple of things I want to highlight. So policies for authentication can be based on a few different things. In this case, you see we have them for groups. So someone who's in the IT group can log in, someone who's in engineering group, or they could be based on different usernames. And actually, I'm going to just go back. But there are ways to create rules based on different conditions. So it could be different user agent strings. It could be based on source IP. It could be based on time of day and so on. So we can create users based on many of these things. There's different ways to configure them. if you want to use regular expressions, if you want to be very specific, and not allow even for changes such as cases. In some instances, in this case, user group, we actually pull information from LDAP servers. So in this case, you don't have to type anything in. It pulls all the groups from your LDAP server just to make it easier. And if I go and I say, let's say domain, it starts filtering. So I might not be sure exactly what it's called, but I know something that's close, it'll actually filter those and allow me to set a condition. So once we set conditions, we can go and create, um, we can add resources. When you add a resource, you can actually create a condition for the resource. So in this case, we're doing it based on usernames, and in some instances, for let's say the intranet, we do it based on user group. We just allow all users to get access to the intranet, whereas other resources are really based on the user themselves. So once we create the policy, you go back to the site, you assign the policy to the site, you assign the authentication method, and you can actually add multiple authentication methods. If you want to do, single factor, multi-factor, you want to allow for the option. The end user has the option to select different authentication methods, and so on. And then the other things that just kind of highlight, we have logging. We have the ability for you to export logs if you want to download them in different formats. I also mentioned the ability to do portal customization. You can go in and quickly create a custom portal. You can upload logos, fav icons. You can point to do your disclaimers and policies. So it's pretty simple. The only thing that's not managed by Zentry is the resource connector. This is something that gets installed on-prem. The configuration is really easy. You give it an IP address and you point it to a DNS server. Then it's an outbound connection. Once it connects to the service, there's a little user token that's provided, and you use that user token to provision the system. So the deployment of the resource connector is like a 20-minute thing, and then the configuration can be a few more minutes. Most of our users that are trying this for the first time and using like local authentication, they can get from initial tenant deployment to first user login in under an hour. And with that, I will pass it back to you, Brian.
Thank you, Asher. That was great. Thank you very much for that super detailed demonstration. I'd like to quickly wrap up. Nothing that you guys haven't probably already heard in this presentation or others, but ZTNA adoption really is growing. It's here to stay. It's displacing VPN as a solution of choice for those three primary use cases, but there are a number of others that it works for. Things like mergers and acquisitions, things like that. So that third-party remote access, enabling employee remote access, and then of course zero trust access to reduce your security profile really does factor in for ZTNA. We've written a ZTNA buyer's guide, and it's on our website. We encourage you to go there and learn more about Zentry Trusted Access, as well as ZTNA in general, and sort of the 10 tenets that I've discussed here. With that, I will turn it over to Scott, and we'll open it up for Q&A.
Okay, great. Thanks, Brian. That was a really nice introduction to ZTNA and Zentry, and Asher, that was a great demo. Appreciate those two views. It's so helpful to see how it looks, for the user and then for the admin. So yeah, we've had a lot of questions come in, so let's get started with those. Here's one. They're asking, what are some other VPN issues to be aware of?
Well, yeah, VPNs have been, don't get me wrong, VPNs have been great for a number of years. They were definitely designed for a different use case, and the pandemic has thrown significant sort of relief onto that situation. It was very much networks in the old days were kind of trust, then verify. And that sort of reflects networks the way they were sort of 20 years ago. VPNs, if they're not managed really fully, can sort of encourage lateral movement in a flat network, and that can increase the sort of, as I talk about, blast radius. They weren't often designed to scale for entire workforces, especially when they're like integrated with firewalls. The firewall often takes precedence. Performance can suffer under load. Users often have to switch between VPNs to access different applications. And they've got those complex clients that can sort of frustrate users and create headaches. So VPNs have been a critical aspect of technology for a number of years, but they're kind of starting to show their age. And threat actors have certainly noticed that, again, that sort of connect first, authenticate second model also is problematic and sort of gives threat actors a bit of a leg up that they really don't need.
Okay, great. Hey, this next question is kind of a follow-up to that, I guess. They're asking, is SDP and ZTNA the same thing? And maybe for my benefit and probably for some other people in the audience, I'm not sure what SDP is. So maybe you could explain that as well if you know.
Yeah, that's a good point. SDP, or software-defined perimeter, was a sort of term that was coined to sort of draft behind the sole software-defined networking hype a number of years ago. Effectively, software-defined perimeters and zero trust network access, they're the same thing. We use ZTNA because it's really more descriptive of what Zentry Trusted Access does. It delivers access to applications and resources for distributed, dispersed, matrixed workforces. And for employees, contractors, third parties, everybody. SDP, it's an older term, and it's still accurate, but focuses more on the resources that are protected rather than sort of what users experience. And so we've kind of migrated over to ZTNA for that reason.
Okay, great. Yeah, and thanks for that clarification. At least for my benefit, if not for anyone else's. Next question here is about deployment. How long would it take to deploy Zentry?
Well, Asher covered that pretty quickly at the very end of his demo. It's basically a lot faster when compared to VPNs. VPNs can take a long time. I know, Asher, you talked a little bit about this in your demo, but can you kind of give a rundown of what it would take to sort of deploy Zentry in terms of when you sort of compare it against a VPN deployment?
Sure. So the only thing that we need to deploy on premise or in the customer's site is the resource connector. Resource connector is like it's basically a lightweight virtual machine that we deploy. And what that does is it's kind of our pathway to get into what we need to access internally. And this is mostly it's an internal AAA server that you don't want to make public, and internal resources. And that the deployment of this, someone asked in the questions about are there any firewalls that we have to modify? So we're using port 443, which is your standard HTTPS port, and we're using port 53. There's nothing else special that needs to be open, and most of our customers, those ports are open anyway to allow outbound DNS connections to like Google, or if they're using something else like a Cloudflare or something that does more secure DNS. Once that's deployed, everything else is just configured on our cloud platform. So typically, if you consider VPN, you would be deploying edge devices, anywhere you want to access things that are internal. Our stuff is similar, but it's not going to be something that you have to open up firewall rules or do natting or any of that stuff. And also from an end user perspective, the end user doesn't have to go and figure out where do I have to connect to. The end user portal will have all of the authorized applications across every single site. So I think the deployment is easier. There's less things to manage, and from an end user experience, it also makes it simpler.
Okay, great. Yeah, and so that answers the question that Bradford had about what would be required as far as opening firewall holes. So thanks, Asher, and thanks for Bradford for that question. Another one here from Andrew that Asher, I think you might have answered in the chat, but I'll ask it in the live session here just so everybody can hear it if they didn't see it there. How would ZTNA work with IoT devices that may or may not have a user associated with them?
All right, thanks, Scott. Yeah, so IoT devices, so there's different kinds, and the two that we've run into there's some that are they're not directly accessible, so they're only accessed through a service management console, and with a ZTA deployment, you would want to allow that access for folks that need it. Mostly it's third parties. What we found is a lot of the IoT devices are actually managed by a third party vendor. So instead of giving the third party vendor a layer 3 connection to your network, they would give them a browser based connection to the service management console itself. So it would be one person gets access to one server, and from that server they can access the IoT devices. There are like PLCs, programmable logic cards, or controllers that allow for direct access, and those are usually done via like SSH. We can allow for that to happen, and those do have service accounts. The service account may not be the specific user account, but we can actually we can create single sign-on that we just put in the known service account. So if I have two IT guys and only those IT guys are authorized to access the PLCs, they'll be the only ones that will actually be presented with the login or the with the icon to log into that. No one else in the organization, even if they clear authentication, will have access to that. So those are the two ways to use ZTNA to access backend IoT devices.
Okay, tremendous. Thanks for that detailed answer. That was great. And you might have all noticed I did put the poll up here on the screen about any additional information that you'd like about the Zentry Security solution. So I'll just leave that up there for another minute or so while we continue with questions, so everybody gets a chance to review that and let us know. We had a question from Abdel Nassar. Will it provide SSO to avoid multiple authentication access to apps? I guess to provide SSO a way to avoid multiple authentication access to apps. Any thoughts on that one?
Yeah, so we do provide SSO, and this is to web-based applications. This could be through like form fills, or it could be through like OIDC. And we also have single sign-on to backend resources. Again, I think in the demo we showed the single sign-on to like RDP. But just to kind of also tackle one of the other questions. So someone was asking about single sign-on. If we provide single sign-on, does that break the kind of the ZTNA model? I mean, the short answer is no. And the reason is that not everyone who logs in will get specific or will get access to everything. So we're giving single sign-on to a resource that someone is authorized to use. If the end user isn't authorized to use it, then they won't even see it. So the single sign-on won't apply. And most people, if they're layering security, they'll have security at the access layer, like how do I get into Zentry? They'll have security at the authentication layer, where it's or the authorization layer, like will I see it or not? And then they may have security at the application layer. The application knows that Azure is trying to log into the build server, but Azure's in product management, and the application itself will deny them access. So you should take a layered approach, and we help with the first two layers, and the application itself helps with the last layer.
Okay, great. And it looks like we're running out of time, but Brian, if somebody wants to get started with Zentry Security or find out more about Zentry and ZTNA, what do you recommend?
Yeah, head over to zentrysecurity.com. There's a contact button there to get a hold of us, and we will definitely get back to you very shortly and learn more about your situation. And we can arrange for things like demos and various other things. Yeah, I encourage everybody to head over to Zentry Security and learn more.
All right, excellent. And so thanks to Brian and thanks Asher. This was a great presentation, really nice demo, and thanks for all the insights in the Q&A. We really appreciate your time today.
Thank you, Scott. Thank you, everybody.
And now it's time to wrap things up with our $300 Amazon gift card prize drawing. And the winner of that drawing is Franklin Owl from California. So congratulations to Franklin. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I do want to thank Zentry Security for making this event possible. And thanks as always for attending and for all of your great questions. That concludes today's event. Have a great rest of your day, and we will see you next time.